welcome to Mathematics with Tom. I am Tom, and today we're going to look at a few more examples of Laplace transform problems. So we're just going to remember that the Laplace transform of some function, we'll call this one y of t, is equal to the integral from 0 to infinity of e to the minus st y of t dt. And once you've taken that integral and you evaluate it at those limits, the t is gone. You're left with a function of s, and we call it capital Y of s. Now, let's try this. We've taken a number of Laplace transforms. Let's try another one. Let's try the Laplace transform of t times e to the at. Now, if I write this in here, this is from integral from 0 to infinity of e to the minus st times t times e to the at dt. Now, you can clean this up one more step, the integral from 0 to infinity of t times e to the minus s minus a t dt. That requires integration by parts. So I'm going to look for another idea. Let's do this. Let's just go back to what we do know. We know this. We know that the Laplace transform of e, I'll write this way, the Laplace transform of e to the at, well, this is equal to 1 over s minus a. Oh, by the way, I would encourage you to try the integration by parts, but I find it very difficult and a good way to make a mistake. And here's another route, though, that I'd like you to see that's just another way of looking at the problem, and it gives it an impressive result. Instead of this, let's think of the problem as this way. Let's take the Laplace transform of the derivative with respect to a of e to the at. And let's do that to the other side of the equation as well. Well, the derivative with respect to a of e to the at, this is going to mean we're going to be taking the Laplace transform. Remember now, a is the variable, t is the constant, so this is t e to the at. Well, this is equal to, now if I take the derivative, this is going to give me, this is really the derivative with respect to a of s minus a to the minus 1. So when we take that derivative, we're going to pick up a negative 1 over, we're going to subtract a power, so that's s minus a to the negative, oops, not to the negative 2, because I'm already putting it in the denominator, to the second, times we have to take the derivative of s minus a with respect to a. Well, that's just going to be negative 1. And so we can say that the Laplace transform of t e to the at is the same as 1 over s minus a quantity squared. Okay, now let's try another problem. Let's put this to work. Let's solve, or we're going to do it, but we're going to transform y prime minus 3y equals e to the 3t. All right, so let's apply the transform to both sides. So that's going to be, we're going to take the Laplace transform of y, of y prime minus 3 times the Laplace transform of y times the Laplace transform of e to the 3t. So the derivative, we know that one, that is s times y of s minus, oh, and I'm going to give it an initial condition. Let's say that y of 0, let's just look at it when it's 0. Okay, so minus 0 minus, and then the Laplace transform of y, that's just 3 times capital Y of s. This equals, and the Laplace transform of e to the 3t is 1 over s minus 3. Let's factor y of s. So if I do that, y of s, I have an s minus 3 equals 1 over s minus 3. Let's solve for y of s. So y of s, I'm going to divide both sides by s minus 3. So I'm going to pick up 1 over s minus 3 squared. Now let's transform y of s to y of t. In other words, use the inverse Laplace transform. Okay, well, when I do that, so y of s becomes y of t. And now look at this, s minus 3 squared. We actually have seen that. We see that right down here. That's what we just proved or derived. So in other words, the a is the 3, and that just says that 1 over s minus a squared, well, that's just t e to the at. So I can write this now. This is very simply as, this can be simply written as t e to the 3t. And notice what happened. If we were to solve this using undetermined coefficients, we would have come up with some kind of a problem when we tried to solve for the case of resonance, but you can see that the Laplace transform handles it well. I hope that helps. Thanks for watching.